students. Welcome to lesson 13, multiply expressions with exponents. We're going to focus on doing our notes, and after you're done with your notes, there's actually a worksheet that goes with it. So again, our notes and then our worksheet, okay? So before we get started, again, go ahead and print out the worksheet so it's easier for you to follow along. You can always pause and rewind and all that stuff, okay? Alright, so again, today we're going to focus on multiplying expressions with exponents, meaning that there will be letters, variables, numbers with exponents. What do? Okay, there's a faster way of doing things, and anyway, so we're going to follow one rule here. If they're the same base, since they're multiplying, we are going to add the exponents. Remember, add the exponent. I know it's multiplying, so you don't actually multiply the exponent, you add the exponent. I'm going to show you why for number one, where you add the exponents. Okay, so let's get started. You're going to see problems similar to this one on your assignment. Alright, so for number one, I'm going to expand. For your assignment, you don't need to expand, but for the notes, I want everybody to expand, okay? So again, that's a negative, so just ignore that for a second. There's no parenthesis, so that negative can belong to something bigger. It could be like PEMDAS or something like that, or part of an equation. So leave that negative alone. 10 to the fourth power means 10 times 10 times 10, so go ahead and do that. 10 times 10 times 10 times 10. And that's 10 to the third power, so that's times 10 to the third power, which is 10 times 10 times 10. As you can see, since they're the same base, you can actually add the exponents, so you can actually just say, oh, okay, that's the same thing as negative 10. That negative doesn't belong to anything, and it's part of something else. And then 10 to the seventh power. Okay, so you don't actually need to do all of this, you can just write it this way. But since they're numbers, we have to multiply 10 times 10 times 10. In fact, 10 power just means 7 zeros. Okay, so negative 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Alright? But for number two, same thing. This one here doesn't have numbers, so that's actually good. You don't need to multiply anything. You don't know what A is as a number. Okay, but we're going to follow this rule. Since they're the same base, you can actually just add the exponent. Again, you don't need to expand. You can say, oh, A times A, and then there's actually 11 of them. Same thing as adding the exponent. Alright? So again, A to the 11th power. And again, you can't do anything there, so we just leave it. Okay? Alright, for number three, again, that's numbers, and they are the same base. I know this one has a negative there, that one could belong to something else. That's another negative. So actually it's a negative times a negative. We are going to add the exponent, make sure there's an exponent there. If there's no number, always put a 1, not a 0, put a 1. Okay, so anyway, so you know that it's going to be a negative. There's one negative there, there's another negative there. There's not 5 negative or anything like that. So it's only 1 and 1 there, so you know it's a positive. So what you're going to get is a positive 2, because negative times a negative is a positive, to the 6th power. Alright? And that's 2 times 2 times 2 times 2. I believe that is 64. Alright. Again, negative times negative is positive. There's only 2 negatives, not 5. Okay, there's 2 positive. Alright, number 4. Now, these two are not the same base, but these two are. So again, treat these two by doing this method here. But these two you can just multiply. So you can see they're multiplying 3 times 2 here, so that's 6. These are the same base, so when you multiply them, you add the exponent and you multiply, you add the exponent only when they're the same base, so it's x to the 6th power. And again, you can't do anything else, you don't know what x is, so you're actually done. Alright? For number 5, again, you want to get ready just in case that you might need to add the exponent, so put a 1 there just in case. Negative 2 times nothing there. You could put a 1 here also if you wanted to. This one's more important, but this one, you can multiply negative 2 times 1. Maybe it makes it easier. So negative 2. And see, same base, add the exponent. So you get m to the 5th power. And there's no other n there. So just enter a second. Okay. There you go, 2 times 1. And add the exponent, and there's no other n. And there you go. Alright? Alright, number 6, negative 11 times negative 9, that gives you positive 99. Oh, forgot to put a 1 there. Always do that first, just in case, you don't know, but just in case you have to add the exponent. But let's do the m first, they're the same base. So you add the exponent, you get m to the 8th power, and then n, you get to use the 1, add the exponent, you get n to the 3rd power. Alright, our notes will continue on to number 7. There's only 10 problems for your notes today. Alright, okay, let's do number 7. Alright, number 7 is right over here. Now, you see there's no multiplication sign, like a little dot. Okay, sometimes and oftentimes they use parentheses. It's just visually easier to see. People don't like seeing a dot. So it means the same thing. So this set is multiplying by this set here. So we can do the same thing. Our main focus is to find the same base and add the exponent. Okay, let's put a 1 here. And I believe there's another 1 over here. Okay, so again, you're ready to add the exponent if you need to. Okay, if you want to put a 1 over here, you can. That's unnecessary. It's just 5 times 1. If there's no number there, you should know it's 5. Okay, but anyway, you just use that. 5 times 1 is 5. Again, they're not the same base, so you just multiply. Alright, this is the same base as this one, so you can add the exponent, you get n to the 4th power. No m there. You can do the v first, so the order doesn't really matter. I just picked the m. There's no other m to add the exponent with. And v to the 1, v to the 3rd gives you v to the 4th. Alright, moving on. 5 times 3 is 15. Again, they're not the same base. 5. There's a 5 and 5 there. You do 5 to a second and then 25. But they're not the same base. You can just multiply. That's actually pretty easy. You can do that. In fact, you want to put a 1 here first. That's important. Okay. Let's take a look on t to the 2nd. There's no other t there, so t to the 2nd. A to the 9th. There's no other a to add the base exponent with, same base. So a to the 9th. You get another v to the 3rd. And then again, there's no other v. And then r to the 1. You don't need to put a 1 there. Sometimes people do. It means the same thing. Alright? Alright, so again, none of them have the same base, so I just rewrote it. Okay. Number 9, again, put a 1 here, put a 1 there. You can put a 1 here, so multiply 19 with. So 19 times negative 1 gives you negative 19. No base with the a, so a to the 3rd. B, nothing, b to the 4th. I get v to the 10th. And then n and n to the 1 gives me n to the 2nd. Alright, let's go to number 10. Again, put 1 and 1 there. That negative. Anyway, so you're going to do 2 times negative 9 with another negative outside of it. I'll just show you how it looks like. It's a positive, but let's just go ahead and do it the longer way. So that's a negative. 2 times negative 9 gives you negative 18. Most of you guys know that's a double negative. Okay, we do that later. Alright, v1 here, so m. There's another m there, so that's m to the 5th power. I have v to the 4th power. And then n to the 1 power. Again, you don't need to put a 1. And your final answer, you can actually make that to a double negative. That's it. Alright, if you have any questions, email me. If you don't have a printer, just go ahead and write out the problems, take some notes, and make sure you do the assignment on a separate sheet of paper. Take a picture of it and send it to me. Alright? Alright, have a great day.